Hello, and thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and today we will be covering what you see on your screen: solving fractions using addition, subtraction, multiplication, and division. All four operations we're going to use to solve fractions. So let's look at the questions that we're going to answer. We got four today. We normally have one or two, but we got a bit to cover. What are the rules for solving fractions with addition, subtraction, and division? What's the rules for solving with multiplication? And how do we handle a coefficient that's a fraction? So we saw here in the beginning, how do you solve this piece here? So we want to, at the end of this lesson, we want to be able to comfortably solve that. So this negative may throw some people off. The fraction may, you're like, what do we do here? So we'll get to that. How do we handle a coefficient that is negative, as we saw there? So you'll be able to answer that problem after these messages. All right, so here's a reminder of the rules. Addition property, it simply says if you have two numbers that are equal to each other and you add a number to both sides that are exactly the same thing, do you change the equation? Absolutely not. It's still equal. It's like having a pen in this hand and a pen in this hand. If I add one pen over here, another pen, it's still going to be two. So as long as I keep it balanced on both sides, adding the same thing is the same thing. Same thing for subtraction. If A and B are the same, say for instance 3 equals 3. If you take away 1 on both sides, let's call C1, it's going to be still equal as long as you keep it balanced. If A is equal to B, the division property says you can divide by the same thing, and it's still going to be equal as long as it's not 0, because you can't divide by 0. Multiplication we'll go over here in a second, but let's look at these three and practice at least one problem. We won't do a ton of problems on each because we've already laid this foundation with more basic integers, so we're not going to go through a ton with this. So, and you'll see what I mean, that we've pretty much already done this. So what do I do to solve for y? Well, I need to get y by itself. I just wanted to say y equals something. Well, the problem here is I have a plus 9 over 16, so I need to do the inverse operation, which means the opposite, which is minus 9 over 16. But the property of equality for subtraction says I need to do the same thing on both sides to keep this balanced. So I know that 9/16 minus 9/16 is 0, so now I really do have just a y over here. But what's 5/16 minus 9/16? Well, if you remember from our training previously, if we're subtracting, we need to have the same denominator. Do we have the same denominator? Yes, we do. Now we can look at the numerators and say, and simply ask the question, 5 minus 9 equals what? Well, 5 minus 9 is just an integer, a simple subtraction integer problem, where we know that our negative number, or what we're minusing, is bigger than our positive, so we know we're going to end up with a negative 4 over 16. And now we simplify this. We can take out a 4, because 4 times 1 and 4 times 4, we can break those into those factors and see that these 4s are going to factor out, leaving us with a negative. I should have made that negative. Negative 1 over 4. So all of that to say that y is equal to a negative 1 over 4. So if I put negative 1 over 4 here, added 9/16 to it, it equals 5/16. And we could test that out and whatnot, but we're not going to work that backwards. But if you wanted to check your answer, you could put it negative 1/4 back here. See if you can add those together to get 5/16. All right, let's do a subtraction problem. I want to get my a by itself this time. I just want a over here. So I need to get rid of this negative 5/9. So I need to add 5/9 to both sides. I'm going to give myself some more room. So adding 5/9 here, and I need to add 5/9 here. Why? Because the addition property of equality says as long as you add the same thing on both sides of the equal sign, you keep it balanced. So why am I adding 5/9 in the first place? Well, I want to get a all by itself so I can solve for a. And negative 5/9 plus 5/9, it just goes to 0. So what is negative 8 over 9 plus 5 over 9? So negative 8 over 9 plus 5 over 9. I see that in order to add fractions, I need the same denominator, which I do, so I can go to the numerator. What's negative 8 plus 5? Negative 8 plus 5 is going to give me a negative 3.
And I know these can be factored more because they both share a common factor of 3, so I can divide 3 out of both. So this is gonna, I can rewrite this to show you what it looks like, what I'm actually doing. So I'm dividing a 3 out. 3 over 3 is just 1, so that leaves me with negative 1 over 3. So that's what my A should be, negative 1 over 3. And lastly, let's do this division problem. Well, this is actually multiplication. 10 times q. So to undo this, I need to do the opposite. Now, a lot of students right here would get confused. Instead of doing division, what do you think the operation that will be often used here? Subtraction. Yeah, because your mind may go to, I want to get rid of a 10, so subtract it. Whatever, we're used to thinking subtract anything that we want to get rid of. But you actually have to undo this operation. This multiplication, you need to do the inverse of it to get rid of it. Well, why, you ask? Okay, let's assume, before I do it correctly, let's assume you did it wrong, so you'll never do it wrong again. So let's assume we subtracted 10. And we subtracted 10. What would that yield us? That would actually yield 10q minus 10 equals 34. Did this problem become any more simple? Not at all. We're trying to get q by itself, but actually we made it more complicated because now instead of just having 10 here, we actually have a negative 10 and a 10 that we need to take care of to get the q by itself. Well, why couldn't we just take away the 10? Because negative 10 and 10q are two different terms that cannot be combined through adding and subtracting. So you can't combine those two just because you say I'm going to subtract 10. Well, you have to subtract 10q. And subtracting 10q causes another problem because now you got rid of your variable, which we're trying to solve for. So let's solve this the correct way the first time. Or I guess the second time. So I'm going to undo this multiplication. So I'm going to divide by 10. And I'm going to do the same thing on both sides to keep this equal. Well, 10 divided by 10 is just 1. So that's going to give me q. 44 divided by 10 looks as so. Now I know these can be simplified because I see that they're both even. So I'm going to rewrite them. I know this is 5 times 2. And I know I have, this is 2 times 22. And that shows me that I can at least factor out a 2. And that leaves me with 22 over 5. And I can't do anything else because 22 is not a factor of 5, has no factors that are in common with a 5, so we leave it this way. And we could rewrite it as a mixed number if we wanted to, right? We can do 22 divided by 5 is 4 and 2/5. 22 divided by 5 is 4. And we're left with 2. 4 and 2/5. So either one of these would be correct depending on how they ask for your answer. Now, what about multiplication? We said we'll get there. So for multiplication, it's the same way. Let's say we have A and B and they're equal. If we multiply C on both sides, it's still going to be equal. So that's the idea. They're still going to be exactly the same. All right, actually, let me show a quick, I feel like I need to show an example of that. So if I had, again, let's use 3. 3 equals 3. And I multiply some number on both sides. Let's call it 2. Multiply by 2 here. Multiply by 2 here. Are these still going to be equal? Yeah, because 6 is still going to be equal to 6. What if I multiply by 10 on both sides? You see the point. It's going to render the same answer no matter what. So what about this? How do I deal with this guy here? Something divided by 7 equals negative 9. Now you can kind of intuitively think about this and think, well, 10 divided by 7, 14 divided by 7, that's going to be 2. And you can kind of work through that. But there actually is a way you can solve this. And you can solve this using multiplication because let me show you how else you can write this fraction. So this fraction can be written as x over 1 times 1 over 7. Why? Because remember, x times 1 is x and 1 times 7 is 7. So this is just being multiplied. So we can rewrite this fraction in this fashion. So why would I want to do that? So let's do that. And I'm going to show you why. X over 1 times 1 over 7. Actually, I'm going to put it in a different order so you can see it even better. 1 over 7. So this is the same thing. Equals negative 9. So I want to get rid of my 1 over 7. Well, how can I get rid of a 1 over 7? Well, I want it to go to 1. Anytime you multiply something and you want to get rid of it, you want to make sure it goes to 1. Other than like adding or subtracting where you want it to go to 0. So what can I multiply 1/7 by to get 1? Well, I know that any number divided by itself is equal to 1. So no one can convince you otherwise of that. So in order to work this one, we need to find out something we can multiply. Anytime we got a number on the bottom especially, we want to figure out what can I multiply in order to get this to go to 1. So you can actually multiply by 7 on both sides. Why 7? Because 7 and 1 over 7 will give you 7 times 1 is 7. 1 times 7 is 7. It's going to make you 49. I'm not 49. It's going to give you 1 because 7 divided by 7 is 1. So when I do this calculation here, 7 times 1/7, 7 times 1/7, this is just going to cross out to give me 1. And now I'm just left with x equals -9 times 7, which is -63. And we can go back and test that, right? We can say -63 divided by 7. Does that equal -9? Yes, it sure does. So that's what the thinking is when you see problems like this. All right, same thing here. We want to get that p by itself. So in order to do that, we're going to multiply both sides by what? I want to get rid of a -8. Well, your first guess may be 8, multiplied by 8, which you'll be almost there, but we want a -8. Because if we don't multiply by a -8, we're going to still end up with that positive. I'm sorry, end up with that negative. But I know by doing it this way, negative divided by a negative is a positive, and 8 divided by 8 is 1. So now this is just going to leave me with p. But I can't just do it on this side, I have to do it over here too. So negative times a negative is a positive. 40 times 8 is 200. And again, we could check our answer. We could put 200 here divided by -8 and see what we get, and sure enough, we'll get -40. But that's the idea when you have a negative in your denominator. All right, what if the coefficient, this is the coefficient, the number right in front of the variable. What if the coefficient is just negative like this? How could we do it? Well, one way you can do it is think of it as a -1, because that's really what it is. It's a -1 equals 15. Now, we didn't solve for this yet, even though it kind of looks like it, but we don't want negative, we want positive y. So one of the ways you could do it is simply multiply both sides, or actually let me start with the way we've been teaching, which is divide by -1 and divide by -1. And that's going to give us 15 over -1. So 15 over -1. Or -15 over 1, however you want to put it. But another way you could have done it is thought of it as a division problem and divided -1 on both sides. Negative divided by negative is still a negative. 15 divided by -1 is still a -15. Either way, you come up with it the same way. All right, what if we have a number in the top and the bottom? So here's what you're going to do for this one. We want to go to 1. We want 3/4 times something to give me a 1. Well, in this case, you're not going to have to do the reciprocal. Hopefully that's pretty close. Reciprocal is when I take a number like 3/4 and I switch the numerator with the denominator, like so. So I'm going to have to multiply that. Why is that important? Because when I multiply reciprocals, I end up with a 1. 3 times 4 is 12. 4 times 3 is 12, and you can see what's going to happen. So I'm going to multiply both of these sides of the equal sign by the reciprocal of 3/4. All right, so this 4 cancels this 4, this 3 cancels. And here's x equals 24 times 4/3. What's 24 times 4/3? Well, we can make this into a fraction by just putting a 1 underneath. 24 times 4, I believe, is 96 and 130. That's 3 on the bottom. Now, can I simplify this anymore? Well, let's see. Looks like there's a factor in 3 somewhere, because I can see that we have a 3, and 9 plus 6 is 15. So I know there's a factor somewhere in here. Let's take it out. So 3 times what gives me 96? 3 times 32. And 3 on the bottom. So those cross out, and I'm left with simply an answer of 32. If you wanted to, you could write 32 over 1, but it's just not necessary. All right, let's go to our next one. One more. This is the one we started with. I want you to pause it here. How would you work this one from our data? Yeah, looks so similar to this one. All right, so hopefully you've paused it and you've worked it, at least tried it. But when we have a fraction here, we want to get rid of this whole thing. So w is by itself in this case. So I'm going to multiply by the reciprocal, negative 8/3. See, the negative times the negative is going to make it positive because I want a positive w. And I'm going to multiply the same thing over here, negative 8/3. Well, I know 8 over 8 goes to 1. 3 over 3 goes to 1. And we have this negative, and I attached it in my head. I didn't say it to you, but I attached it in my head to this 8. Negative 8 divided by negative. Now, it doesn't matter which one you do. Just make sure if you want to get rid of the negative, you're multiplying or dividing by a negative. So this is going to go away to just w. And I got to multiply 7 over 72 times negative 8 over 3. Not 33. And I know that this is a fraction. So I can just multiply straight across here, but I don't want to get these big numbers. So I'm going to see if there's anything I can factor out. And I see that 3 and 72 have a common factor. So what is 72 divided by 3? 2, 12. So 2, 6. 2, 6, 1, 12. There you go, 24. So that gives me 24. So I know this 72 is 3 times 24 and times 8. And this is all going to still be negative. Keep that negative sign here from that 8. It's going to make that whole thing negative. And on the bottom, we just have 3. So I can see that I'm going to cross out my 3's, and whatever 24 times 8 is going to be my fraction. So 24 times 8, what's 24 times 8? I'm trying to do it in my head. 24 times 10 is 240. Take away 48, and you're going to have like 196 maybe. So let's do that. 24 times 8, 32. 8 times 2 is 16. 17, 18, 19, 192. I think that's what I said. 192, we're going to remember to keep that negative because we had a negative 8 here. So 192. Let me review that real quick because it started to look a little bit messy. All we did was multiply 72 times negative 8 over 3. And that's what we're doing right here. To make it a little bit easier, I broke it down into some of its factors so I can cross out a 3, leaving us only with 24 and 8. 24 times 8 is 192. And we left it negative because we got negative times a positive is a negative. That's going to do it for us. Did we accomplish our goals? What are the rules for solving fractions with addition, subtraction, and division? We saw that with the properties of equality, where we had to add the same thing or multiply the same thing or subtract the same thing or divide the same thing on both sides. So that's the rule for multiplication as well. How do we handle coefficient as a fraction? Well, we talked about it, right? So if we multiply 3, 2, negative 3 over 2, x equals 10, we're just going to take the reciprocal. So whatever the reciprocal is, which is in this case negative 2/3, and we're going to keep that same sign that it has. How do we handle a coefficient that's negative? If it's just negative, like negative x plus 3, I'm sorry, too complicated. Negative x equals 3x plus 10. Well, how are we going to get, I don't want an x right there. Let's say negative x 30, I made that more complicated than it needs to be. So if you just have this right here, how do I get rid of that negative? One, you could divide by -1 on both sides, or you can what? You can multiply -1 on both sides. Either way, a negative times a negative is a positive, so negative is going to give me that positive. Positive times a positive is going to give me a negative. Positive times that negative. All right, guys, I hope that was helpful. Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.